I would like to welcome you all in the playlist of project discussion. This video, I'm going to discuss a project which you can develop for the campus or for your incubation center. So kindly note down the title, that is Development of Smart Underground Drainage Leak Detection System and Localization using Acoustic and Pressure Sensing with TinyML and Internet of Things. You might have seen a lot of underground trenches and a lot of underground pipes for a drainage pipe. In case any fault is occurred, it is very difficult to identify where the fault is occurred exactly because we have to go for like a manual and labor work that is too tedious. Ultimately, you may not find it out where exactly the leak is happened. So to overcome that, we are going to develop proposing a new system such a way that using the ML and IoT, you are going to identify where where exactly the damages happen in the uh, like underground pipe. So this project can be applied for like a like apartments, multi-storage systems, and like industry, chemical industries, correct? Where there is a so many number of drainage pipes which is like trenched or which is buried under ground. So by using the system, you can easily identify where the fault is exactly happening. Okay. So moving on to the discussion, this project you can go for like either mini project level or major project level also. Also, like this project gives a scope for writing a paper. That is another important thing. Yes. Now let us discuss about a brief idea about the project. So as you can see, we'll have an overview about the project. A tabletop buried pipe test bed that mimics an underground drainage line because you need to show the prototype. So just you can prepare a test bed. A small water pump circulates water through the PVC pipe buried under the soil. We can use the sand or a soil and make a small area, right? Similarly, intentional leak points. You have to identify the intentional leak point. You have to put a small valves or you can put a small holes which can be opened and simulate the leak. Similarly, we need a sensor and the following sensors are used. Then acoustic sensors or vibration sensors, then pressure sensor, then soil moisture sensor. These are the physical sensor which you are going to use the system. Moreover, we require a microcontroller unit. I'll tell you what kind of microcontroller unit that is going to use. That is ESP32, you can use it. Similarly, we need a set of data. Okay, so like data related to the system that is needed. Similarly, we can say a data is processed on device with a tiny ML classifier. We are using the machine learning technique. You can identify any other efficient ML classifier is available. You can go ahead. And also leak storing logic can send via Wi-Fi to the dashboard. Okay, because we are using IoT and we are supposed to have real-time monitoring. So the output of the ESP32 is directly given to Wi-Fi module, then Wi-Fi module will be given to the cloud. Through the cloud, you can have a thing speak and you can have a better visualization. The system directs if any leak exists. So based upon a predetermined data, that means it's a data-driven approach. If any leak is present, it is going to identify. And it estimates the location along with the pipe by comparing the sensor pairs and the flow pressure drop. So that's what exactly happening actually. You are intentionally making a hole, then like it estimate its location along with the pipe by comparing the sensor pair. And also like a pressure drop. In case any hole is, if you make a hole, as I already told you that there is a water circulation. In case you make a drop, what is going to happen? There is a sudden pressure drop. So that pressure drop also based upon the pressure drop, where the pressure drop is happening, you can identify the location where the leakage is happened. So for your betterment, I prepared one simple block diagram. I have made a hand like a free sketch only, freehand drawing. So we have water pump. As usual, you are circulating the water instead of like a drainage. It's like a mud water or dirty water. So you are using the normal water only because this for a demonstration purpose, right? Then you are going to create a pipe loop. So it will be underground and like you can use the sand or soil and let the pipe buried under sand or soil. Create a leak. Okay, create a small hole or a wall. Wall is better actually. It's openable, right? Yeah. So then we need a piezoelectric sensor, then pressure flow sensor, and a soil moisture sensor. You have to keep in different position. All the output of a sensor is given to node MCU or microcontroller unit. Here we are going to use ESP32. And the power supply, you can use it like even for solar power can be used. It's optional, right? Next, what you can do, you have to do the coding accordingly. So you decide the variables, decide the inputs, and you have to create exact what exactly you want. That you have to code exactly. Okay, using the compiler C, you can code it. Next, we have a Wi-Fi module for the communication. Okay. The Wi-Fi module is fed to the cloud platform. Okay, where the data is going to be stored in the cloud. So output of a cloud is directly given to ThingSpeak. You can observe what is happening in the real time, like checking the pressure level, checking the moisture content, checking the variation in the pressure. All the things can be measured through the ThingSpeak output. Direct live output you can observe through any kind of devices, even mobile devices also you can use it. So this setup can be used for the chemical industry, especially. Okay, because most of the, especially most of the factories, we have so many trends, we have so many drainage pipes which will be circulating throughout the outside and inside the campus. Correct. So now, what you can do is here you can use the data-driven approach. So already data is available in the cloud platform. Here you can introduce the TinyML classifier or any other convenient machine learning. Then we have a decision-making layer. Here we have different options. If you want, you can add more options. Yes, leak is detected. There is a leak. No leak present. That means nothing happens. Everything is fine. System is healthy. Your drainage pipe is healthy. So there is a minor leak. There is a small leak which may expand it in future. So these are the different options. Then it is fed to the output layer. Output layer is fed to the microcontroller so that the code is going to be modified accordingly. Correct? So it's a basically data-driven approach. So please focus on this diagram, you will understand. So I'm expecting you can make the a small pipes in this particular order. Small like a small box you can put up. Because we want to show a demonstration, right? So we are expecting the pipe which is buried under the sand or soil in this fashion. So regarding the data path, raw acoustic vibration. So we need a bandpass filter with a frequency of 500 to 5000 hertz. Then we have a the special parameters like a band energy, then spectral centroid, then RMS, etc. Then it is we are using them like a TinyML classifier with three to four options. You can take a different decision. Leak is happen, no leak, minor leak, major leak. Then regarding the pressure flow, the pressure drop delta P and flow rate Q, there is a relation between pressure and discharge that you have to identify. The leak source boost when pressure is more, discharge is high for some pump speed. Soil moisture, then binary seepage flag near to the suspected region. So these are using this sensor you can make out. So three sensors actually: acoustic sensor, pressure sensor, and a soil moisture sensor. You have to place it accordingly while designing. You need to identify the position as well. With respect to localization, compare S1 and S2 energy time lag, estimate the segment of leak. So based on the position of the sensor, and we can identify the difference. If you compute, you can identify where exactly the fault is happened. Okay. So these are the basic strategy you have to apply. So moving further, the pin mapping is already mentioned here in the ESP32. You can make use of these channels. Correct? We have different CS0, CS3, CS6, CS7, CS4. So please make use of these channels. Okay. So we have the bandpass filter. Okay. Like a 500 to 5000 hertz. That is second order active. Okay. With respect to the mechanical and test bed setup, so we are going to make a sealed tub like a plywood box with a plastic linear, then fill with the 15 to 20 centimeter compacted sand so that your pipe will not be visible. So same you are going to demonstrate as if you are doing the real time, correct? Lay a PVC loop, U-shaped or rectangle I shown already. Then 2 to 3 inspection points exposed to on the top that you can observe. Insert the leak holes or valve. Valve is better because you can do different type of testing. First case, no leak. Second case, open the valve. Correct. Identify at least 2 or 3 location you can identify. Keep them normally closed. Okay. Then if you want to create the fault, just open the valve. That means it will act as a hole, right? Mount that mic or piezo S1 near to the pump inlet inside, then mic piezo S2 near to the remote end to identify where the fault is occurred. That use clamp and silicone pad to tight the coupling. Correct. Use the proper coupler. Then add pressure sensor, pause pump, and flow sensor on return. So the soil moisture sensor also placed over there. That means 5 to centimeter above the pipe of two suspicious segments. We have to place the soil moisture probe accordingly. Connect the pump to 12-volt supply, just like can use the small type of motor, PWM motor driver, to vary the flow. Okay, PWM motor means like you can change the movement. Water flow also you can change by changing the pulses. By changing the duty cycle, you can control the flow of water also. Simple motor, like a simple motor, you can purchase from different websites. eBay, you can check out. Even RoboKits. So many websites are available. You can purchase it directly online. With respect to the software, the data acquisition, we like sample vibration channels of 10 kilohertz, then read the pressure up at the 100 hertz. Similarly, calculation of change in pressure, like a count flow pulses, that means it will be measured with respect to liter per minute, and read the soil moisture for every 1 seconds. Similarly, with respect to signal processing features, time domain, we are going to measure in time domain, like following parameters such as root mean square, then peak, crest factor, kurtosis, etc. So with respect to frequency domain, these are the things which are applicable to design part. FFT, band energy in 0.5 to 1 kilohertz, 1 to 2 kilohertz, 2 to 5 kilohertz, spectral centroid, etc. With respect to another parameter, that is cross sensor, energy ratio E1 by E2, GCC, PHAT, time lag, all the parameters should be considered for localization hint. I mean, how to identify the exact location where the fault is occurred. TinyML model for the decision making, labels, no leak, small leak, big leak. You can up to different like a decision you can make out. Model like a small one-dimensional CNN or RFC random forest. Train Python convert via TensorFlow light into micro. On ESP32 input features, all the sensor will be given to the microcontroller unit. Output will be like a classes and a confidence. So you have to connect the connectivity and dashboard for having the better visibility. What exactly happening? Okay, so you can have a better visibility. We are going to enable the dashboard. Even calibration and data set collection, like a baseline. So create the pump on, all leak valves are closed. Record different condition to check whether initially you have to make everything closed and make it healthy. Later you have to open the valve and create the fault condition. Small leak, open at least one valve, zero point 0.5 to 1 millimeter equivalent, record 5 minutes. Then big leak to open the wider range. Okay, open the valve in wider range. So because if you use the valve, you can easily control, right? Repeat the steps for 2 to 3 valves and two. Even parallel, you can measure when the fault. Time also you can, time is one of the important parameter. Then export a CSV file like features, labels, split 70, 15, 15 train wall test, depends upon your requirement. Then tune the threshold and save the trained like a TFLM model and flash to ESP32. Okay, then performance target is in this fashion. Detection accuracy will be greater than 90% on the test set. Even false alarm rate is less than 5%. And the localization, correct segment, where exactly happened in the leak. Then implementation plan you can make within 1.5 months. In the first week, you can go for like a test bed build. Second week, you can go for like an analog front and then ESP32 data logging to personal computer. Then third week, you can go for feature extraction in Python, model training, Python coding and all. You can go for third week. Fourth week, you can go for like a development of a TinyML, implement the fusion and localization and threshold tuning. Then fifth week, go for validation of experiment, stress test, different soil, moisture, pump speed, etc. Week number 6, paper writing and figures and demo polishing and go for reporting. Within 2 months, of course, we can complete the project. So experiment to prove the works. Then flow variation, soil conditions, distance effect, robustness, all the parameter you can do the testing effectively. So block diagram you are expected to draw as I have shown you early that you can modify if you want. Analog front end, features pipeline, then test bed layout, you have to plot the result also, confusion metrics, then a region of convergence, time series with the leak annotation, all those things you have to add. So approximate cost is around 10,000. Within 10,000, you can manage this project within AEC. Even you can apply for the funding also because we need these like a new technique nowadays because we are facing so many issues. the pipe which is buried under the ground, it is very difficult to troubleshoot, very difficult to identify where the error is occurred. Correct. So this project will really help us save a lot of money and time. Even labor effort also can be minimized. Even accurate result can be predicted compared to the previous one. So the we need sensors, acoustic and a pressure sensor, pick the signal from the pipeline. We need a signal conditioning devices to remove the noise and prepare the data. Microcontroller collects and synchronize the readings. Even feature extraction find the useful parameters, especially sound, frequency, pressure, etc. TinyML rule-based logic to check the signal match the leak pattern or not. Just like a decision, like a small leak, big leak, no leak, etc. Leak decision. If leak is detected, system moves to localization. Localization estimate where the leak which is happened. IoT transmission sends the data to the cloud. Even dashboard shows the leak alert. So health status and localization. So someone will understand that this leaking is happened immediately. They will turn off the pump. Even that also no, I note uh, standard manner you can automate it, you can do it. Then user notifications send the mobile or web applications. So thank you for watching this video. So same project you can develop it as a paper. If you want, I will guide you and I'll make a separate video. If you don't have any queries, do let me know. So this session will be useful for like a interdisciplinary branch project. Even computer science students can carry out. There is nothing wrong. Okay. So thank you so much for watching this video. I wish you all the very best for your examination and project Viva. Happy learning. Thank you. Thank you all.